Welcome to this in-depth session on strategic utilization of coke undersize in blast furnace operation. In an era of rising PCI rate and cost optimization, how we manage our nut coke is really very important, and it gives a way to the entire economics of hot metal and its cost management. So we can say that managing nut coke and screening a strategy is not just a housekeeping, rather it's a high impact metallurgy. As PCI injection increases, reliance on coke shift tremendously. All we know, because as we start injecting PCI, or ore by coke ratio increases as coke we have to take away from the main course, and we have to supplement in form of injectant. Now, when this coke taken away from the main course of menu of Boden menu, then our differential keep on increasing. What we say that at a higher dp we have to operate the furnaces, and here we have to make a balance of burden descent, stability, everything we have to see. So managing this undersized coke is one of the very important aspects in uh, mm, burdening, and this generation also depends on how the blast furnace department has configured their their coke screen. So uh, we can say that undersized coke, which is often dismissed as a waste, uh, can be repurposed for sintering, pelletizing, or directly reintroduced into the blast furnace also. So it is not about just discarding; it is about a discipline redistribution. As a control portion of uh, um, undersize fraction of coke, one fraction is coke breeze, which plays a vital role in center bed permeability and ignition. For pellet plant, a small volume enhance carbonability, but particle control remains critical to avoid fines overload. And in this sheet it is nicely mentioned that and is a very optimal way this table is configured, so that the operator can get a help around which fraction they are there and what is the generation. So this is a basically navigating template sort of thing here. So the remainder of the undersized coke finds its way back into the furnace burden. Here optimization matters, and oversaturating ore layer with nut coke can disrupt permeability and encouraging gas bypass also. So a smart blending is important. So we have to configure as per our perforation at a coke screen and the furnace burden texture. We have to blend accordingly. Now coming to the configuration of a nut coke, as we are knowing that a small blast furnace tolerate higher nut coke ratios, and adjusting a screening aperture allows operator to match coke fraction to furnace dimensions. That is an essential move to balance gas flow and maintain wall friction threshold. And uh, as this chart shows, the aperture size dramatically alter nut coke percentage. So a 40 screen yield over 30%, which we can say it's too high. At 35 the nut coke fraction dropped to a manageable of 70 17%. So we have to see that at what screen fraction, what sort of volume of nut coke is getting generated, which is subsequently to consume in blast furnace. And if this process we see at 35 course, we can see we have a generation of around 30%. And once our generation of nut coke is 30% in a bigger furnace, this band is not easy to assimilate, because whatever nut coke we are putting in furnace, it should be consumed in gasification reaction only, so that our hearth can be safer and it would not be clog up. Hence, there will be a no permeability issue of dripping metal and slag through the grids, and finally, subsequently, our tapping will be more efficient. Hence, we need to take a band of nut coke around 17%, which is very moderate. And at this band, we have a perforation of 35 center screen, coke screen. So at this generation of nut coke is 17%, which is very favorable, and in a bigger furnace it is a very suitable band where we can maximize our production, and it is cost effective also. So we can say that coke screening is not just a mechanical separation that we have seen earlier. It is also fuel conditioning. A 35 aperture represent the best compromise between reusability and furnace health. Screen smarter, and then we can say that melt smarter as well. So with a smarter screening, we have a smarter melting also. So we can say that with the larger aperture, thin out the coarse cochlear, but improving the gas permeability. Yet in this situation, they generate more nut coke, which must be blended wisely into ferrous layer, and ignore this balance. And if um, uh, if such type of thing, if we proper if there is a no balance of proper portion of coke, then we have a risk of burden collapse, or we have a erratic descent also, which is detrimental for furnace operation. So in closing, we can say that optimizing undersized coke utilization demand a furnace specific strategy, and calibrated screening, targeted nut coke reuse, and an adaptive mindset for high PCI regime is always required. And this is not about only coke management, it is a small and a smart fuel engineer.